Hello students, so we'll move on with the second chapter of module 2, that is process scheduling. This is an important chapter from your career point of view as well as a semester exam point of view. So in this first topic, that is CPU scheduling. What do you mean by CPU scheduling? So in simple words, if you're saying we have processes which are ready to execute, so giving the CPU to the process so that process can execute, that is called as CPU scheduling. So we might have n number of processes which are ready to execute. So out of this n number of processes, which process you have to take and give to the CPU, that decision is being done by the scheduler. Okay, so scheduler is the one which is going to decide which process should be taken and given to CPU. So the process of giving the control of CPU to the process is called as CPU scheduling. Okay, so when you say processes, okay, so it consists of CPU and IO burst. So process execution consists of cycle of CPU execution and IO burst. Okay, or the process can do CPU related job as well as input output related job. Processes alternate between these two states. Process execution begins with CPU burst. Okay, so in the beginning it will be performing CPU related job, followed by IO related job, followed by CPU, IO, and so on. Okay, so CPU burst is nothing but duration of time the process using the CPU for execution, or in simple words, if you're saying process is doing some job related to CPU, whereas IO, the process is doing some job related to input output. Okay, so usually we say process is a combination of CPU related job as well as IO related job. So to say a process, so we can say a system should have a good performance if and only if, or system will have good performance if and only if it has a good combination of CPU as well as IO burst. Because if you have a process which is doing only IO related CPU related job, then what happens, CPU will be busy all the time, but what about input output device? They will be simply sitting idle. Or if you have only IO related job, in that case what happens, CPU will be sitting idle. So for a good performance you should have a good combination of CPU burst as well as IO burst processors. Okay, next we'll come to non-preemptive scheduling and preemptive scheduling. So you must understand the meaning of preemptive and non-preemptive. So in simple words, if you're saying non-preemptive is a one which cannot be stopped in between, or forcefully you cannot stop, whereas preemptive means forcefully you can stop or take away something. Okay, so we'll come to the definition here. A scheduling discipline is non-preemptive if once the process has been given the CPU cannot be taken away from the process. That is cannot be, that is non-preemptive. Forcefully you cannot take the CPU away from the process. The process on its own should give away the control of CPU, that is called as non-preemptive. Whereas in case of preemptive, it is possible, that is it is preempted. So when a process is updating data, it is preempted so that second process can run CPU scheduling decision. Okay, so what we are saying here in preemptive, what are we saying in preemptive? So you might be having a process which is updating some data. Okay, so in between you can stop that and give the control to the next process, that is called as preemptive. So in simple words, if you are saying preemptive is you can stop, whereas non preemptive is cannot stop. Okay, so the process on its own should give away the control of CPU, that is non-preemptive. So CPU scheduling decision can take place under the four circumstances. So the four circumstances when you can perform CPU scheduling. So what is CPU scheduling? Giving the control of CPU to process. So when it can be done, when a process switches from running state to waiting state. So we have already seen the process states. So from running, when it is going to waiting, when it will go from running to waiting, suppose the process wants to do some input output related operation, then it will switch from running to waiting. That time you can perform CPU scheduling. When a process switches from running to ready, when it will go from running to ready, when there is an interrupt occurred, or whenever a higher priority process comes in, then the process will switch from running to ready state. Okay, when a process switches from waiting to ready, so waiting to ready, when it will go from waiting to ready, so process was doing some input output related operation, so it has completed that input output related operation, then it can go from waiting to ready. So I hope you remember new, ready, then you had running, then you have waiting. So I hope you remember this process life cycle. So the same thing is told here, and the four circumstances when the process terminates. So these are the four situations when process scheduling decision has to take place. Okay, next we'll come to dispatcher. So dispatcher is responsible for giving the control of CPU to the process selected by the short term scheduler. So short term scheduler is going to decide, so if there are three processes which are ready to execute, out of that three process, which one you have to take and give the control to CPU, it will decide. And dispatcher is responsible for giving the control of CPU. Okay, this functions involve context switching. I hope you remember context switch. That is, you're saving the state of the old process in the PCB and you're loading the state of the new process. Okay, CPU will switch to the location depending on scheduling algorithm when process gets started. So to which location you have to go based on the algorithm. Switching to user mode, these are the functions associated with dispatcher. Jumping to the proper location in the user program to restart the program. So these are the functions. Dispatch latency, just know this term, dispatch latency. Time it takes for the dispatcher to stop one process and start another. So suppose you have one process starting at 9 a.m. and it is going on, and process P2 it will start at 9:10. Okay, so what do you mean by dispatch latency? Time it takes for the dispatcher to stop one process. So suppose at 9:05 this has stopped. Okay, and start the running process. Okay, so suppose if you consider this, then this will be 5 minutes, that you can call it as a dispatch latency. Okay,